In this lecture here, we're going to start talking about zeros of polynomial functions. So we have only three objectives in this lecture. We want to use what's called the rational zero theorem to find possible rational zeros. So this is important. This is just possible. You know, if it has a rational zero, what does it look like? What are the possibilities it could be? Then we want to find the zero of polynomial functions, and then we want to solve polynomial equations. And I'm going to do all three of these objectives in one single lecture here, and it's going to be a little bit long. And you're going to notice that the problems are going to be rather difficult and rather lengthy, and they're going to involve a lot of steps. So what I have here is I have basically, I'm going to do one example of the rational zero theorem, because that's going to come up in each of the following two sections. And then I have three examples that work through how you find zeros and solve polynomial equations. And there's gonna be a lot of steps, so I encourage you to pause the video, work the problems with me as we go through, because it can be a little confusing. Okay, so let's start with the rational zero theorem. So if you have some function f of x, okay, and it looks like this: a to the n times x to the n, or a sub n times x to the n plus a to the n minus 1, x to the n minus 1, so on. This is just the equation of or the form of a polynomial function. Okay. Now, if it has integer coefficients, so these a sub n minus 1, a2, a1, a0 are integers. Okay, they need to be integer coefficients. Okay, so these are like -3, -2, -1, 0, 1, 2, integers, 3. Okay. And p divided by q, where p divided by q is reduced to lowest terms, all right, is a rational zero of f. So if f of x, basically what this is saying, if f of x has a rational zero. So a rational, what it means, like a rational number, so a number that looks like a fraction, okay? So it has a rational zero, we'll say p divided by q, all right? Then it turns out, believe it or not, that p is a factor of the constant term, that's a sub 0, okay? So the constant term at the end. And q is a factor of the leading coefficient, a sub n. Okay? So it turns out, if it has a rational zero, this is really cool actually. If it has a rational zero, it turns out that the rational zero is a fraction of the form where the numerator p is a factor of the constant term, and the denominator q is a factor of the leading coefficient. Okay. So it seems a little confusing, but trust me, after you see a bunch of examples that I do through the lecture here, it'll make sense. Okay, so here'll be the first example. Let's list all the possible rational zeros, okay, of this function, okay? So I have f of x is equal to 4x to the 5th plus 12x to the 4th minus x minus 3. Okay, so our constant term is this -3, okay? And then what is our leading coefficient? Well, that's just 4. Okay, so the possible, so this is what, if it has a rational zero, what does that rational zero look like? So I'm going to write out what all the possibilities are. That doesn't mean that every single one of the possibilities is a rational zero. All it's saying is if it has a rational zero, an x-intercept, right, the zero, what could the possible be? What could it be? What could it be? It'd be a number from this list. Okay, so the possible rational zeros, all right, are going to be, all right, so just going back real quick, okay, it's a factor of the constant term, so it's going to be a factor of -3 all over a factor of the leading coefficient, so all over a factor of 4. Okay, so you have to think. This is what happens. What do I mean by factors? Okay, so like what numbers multiply together to get you to be minus 3? Well, you could have 1 and minus 3, or you could be minus 1 and 3. Okay, those are all numbers that multiply together to get you to be minus 3. So I'm going to write this. It could be either plus or minus 1, or it could be plus or minus 3. Now, what are the factors of 4, right? So it could be, this is where it gets a little complicated. 1 and 4, it could be minus 1 and minus 4. What else could it be? It could be 2 and 2, or it could be minus 2 and minus 2, right? So there's a lot going on there. So it would be plus or minus 1, plus or minus 2, or plus or minus 4. And it could be all combinations of this, right? So it could be 1, it could be positive 1 over 1, it could be positive 1 over minus 1, it could be positive 1 over 2, it could be positive 1 over minus 2, it could be positive 1 over 4, positive 1 over minus 4, and then it gets like, even crazier, right? Then it could be minus 1 over positive 1, minus 1 over positive 2, minus 1 over positive 4, and so on and so on. So it's all combinations of all these things. So it's a lot, okay? It's a fair number of these. And this is where it gets complicated, right? So like when you have these large numbers of these, how do you know which one is the actual 0, right? Like you have these long lists, so like what is the actual 0? And that's what we're going to work on in this next section. Okay, so I'm going to pick one with a little bit less combination so it's a little bit easier. Okay. So let's find all the zeros of this. Okay, so we have this function here. F of x is equal to x cubed plus x squared minus 5x minus 2. So I don't just want to list all the possible ones. I want to find all the actual zeros. So I want to find all values of x that solve this equation. X cubed plus x squared minus 5x minus 2 is equal to 0. All right. Whew. So you're going to notice that as I go through this problem here, it's really lengthy. Okay. So the first thing you're going to do is you're going to list all possible rational zeros. Okay. So the possible rational zeros. Okay. Well, what is my constant term here? So it's factors of -2. Okay. And what is my leading coefficient here? It's 1. So it's factors of 1. All right, so what two numbers multiply to -2? It's either 1 and -2 or -1 and 2. So the two possible things you have plus or minus 1 or plus or minus 2. All right, and then similarly here, what are the factors of 1? Well, it has to be plus or minus 1. All right, so I'm going to list out all the factors here, right? It could be, you don't have to worry about a negative divided by a negative here because that's just a positive. So it would be positive 1 over 1, which is 1, or it would be 2 over 1, which is 2. And then similarly here would be -1 and -2. Okay? So now, here's the thing. What you have to do now is you have to use, okay, so this is where it gets a little confusing. I don't know which of these, okay, I don't know which of these is the actual rational zero. So next is like, how do we find which one is the rational zero? And so it seems a little confusing, but what we're going to actually do is we're going to use synthetic division. okay? So I'm actually going to start with, let me just take a number here. Let me just take 1, okay? So is x equal 1 a rational 0? Okay, that'll be the first thing we do. So watch what I'm going to do here. So I'm going to go to the next slide here, okay? So my function was f of x is equal to, it was x cubed plus x squared minus 5x minus 2. Okay, minus 5. So is x equal to 1 a rational 0? So what I'm going to do is I'm going to set up synthetic division. So I'm going to put 1 here. I'm going to put the coefficients, right? 1, 1, minus 5, minus 2. So you're just going to plow through synthetic division. So bring down the leading coefficient. 1 times 1 is 1. 1 plus 1 is 2. 1 times 2 is 2. Let's see. Minus 5 plus 2 gets me minus 3. And then 1 times minus 3 is minus 3. Minus 2 plus minus 3, minus 5. Do you notice how this has a remainder? What this means, if I were to take 1 into the function, it would actually equal negative 5. Okay, so this, since we have a remainder, x is equal to 1 is not a rational 0. All right, so what you're going to have to do is you're going to have to repeat this process, okay, until you find a rational 0. So here's what I'm going to do, okay? I'm actually just going to pick a different, no, I'm not going to use negative 1. Let's actually try 2. Okay, let's see what happens when I use 2 here. So I started with 1. It didn't work out. So let me try 2, okay? So I'm going to put 2 here. All right, so bring this down. 2 times 1 gets me 2. 1 plus 2 gets me 3. 2 times 3 gets me 6. Let's see. Minus 5 plus 6 gets me 1. And then 2 times 1 gets me 2. Remainder of 0. Okay, so what this means, since the remainder of 0, this means that x is equal to 2 is a rational 0. Okay, boom, yes, we got it. We got it. So what does that mean? Okay, so believe it or not, we're like almost there, okay? So let me go to the into the next slide here. So we had our function. What this means, since this is a rational 0 here, notice that when I perform the synthetic division, okay, I'm left with, remember what this is. This is 1x squared plus 3x plus 1, okay? So this right here, if I bring the 2 over, what this means is that this becomes x minus 2 times x squared plus 3x plus 1. Okay, this, if you were to multiply this out, would be the same thing. That's what we got when we did the synthetic division here. Okay, so now I've taken this. Okay, I've taken my function, performed synthetic division, factored out basically the rational 0 here. Okay, I found it, and now I have to solve this resulting equation because I wanted to find the 0. All right, so look here. I can use the 0 multiplication property. So x minus 2 is equal to 0. So one solution here is x is equal to 2. and that's what we found with synthetic division, or I need to solve this. Well, so how are you going to solve this resulting quadratic equation here? Well, there's no, you can't factor it, so you're going to need to use quadratic formula. So x is equal to negative b, okay? So it's minus 3 plus or minus the square root of b squared, so that's 3 squared, minus 4 times a times c, all over 2a, all over 2 times 1. So this is x is equal to minus 3 plus or minus the square root of 9 minus 4, all over 2. So x is equal to minus 3 plus or minus the square root of 5 over 2. So I got two solutions here, right? So the zeros of this function. So my function was originally f of x is equal to x cubed plus x squared minus 5x minus 2 are. So this is my solution set. It's 2, and then it's minus 3 minus the square root of 5 over 2, and then it's minus 3 plus the square root of 5 over 2. And I was able to do this, okay, by using this synthetic division in the rational zero theorem. All right, I know. It's like, whoo, there was a lot going on in that problem, okay? So let me do another one here so that it'll make, you can see the process again and have it make sense. So we're going to go through the same process, okay, in this next example. We're going to list the possible rational zeros. We're going to use synthetic division. And then we're going to solve the resulting equation after we use synthetic division. All right, so here will be the problem. Let's find the zeros of, let's look at this function. F of x is equal to 2x cubed plus 6x squared plus 5x plus 2. Okay, so the first thing we're going to do, we're going to use the rational zero theorem to list possible rational zeros. Okay, so the possible rational zeros so it's factors of the constant term, so factors of 2 all over factors of the leading coefficient, so which is also 2. So look, so factors of 2 are going to be plus and minus 1 and plus and minus 2, and also the same thing down here. So plus and minus 1, plus and minus 2. All right, there's a ton of them here. Okay, it could be plus or minus 1, it could be plus or minus 2, and then it could also be plus or minus 1/2. All right, so you have 2, 4, you have 6 different ones, okay? So to use synthetic division, what we're going to do is we're going to concentrate on these integer ones, okay, and not worry about the fractions, okay? So let's try, so again, next, use synthetic division to find the rational zero. All right. So let's just test. Let's just test to see like 1 here. Okay. Okay. All right, so let's test to see if x is equal to 1. Is a rational 0. Okay. So let's, bring the coefficients over. 2, 6, 5, and 2. So bring down the 2. 1 times 2 is 2. 6 plus 2 gets me 8. 1 times 8 is 8. Let's see, 5 plus 8 is 13. 1 times 13 is 13. And 2 plus 13 is 15. Okay, so we got a remainder. Okay, so we see x is equal to 1 is not a rational 0. So you could go through this all again, but so let me just help and show you what the next one will be. So let me just see. I've got a lot of pluses in here, so it's probably going to be a negative number, one of the rational zeros. So let me try -2. So again, my function was f of x is equal to 2x cubed plus 6x squared plus 5x plus 2. Let's see if x is equal to -2 is a rational 0. So you're going to have to do the synthetic division. Okay. So bring down the 2. -2 times 2 gets me -4. 6 plus -4 gets me 2. -2 times 2 gets me -4. 5 plus -4 gets me 1. And -2 times 1 gets me -2. Boom. Remainder is 0. Okay, so we see thus x is equal to -2 is a rational 0. Okay, so what happens is I can take my function now. Remember, this, when I divided this through, this is now x squared x. So this means my function f of x is equal to 2x cubed plus 6x squared plus 5x plus 2 can be written as, I'm going to bring this over, x plus 2 times 2x squared plus 2x plus 1. All right, now you can see what's going to happen here, right? So now I have to solve this, because the original problem was to find the rational zeros. Okay, so let me bring this all over. Okay. So now we want to solve this. We want to take my original function, f of x is equal to 2x cubed plus 6x squared plus 5x plus 2, which was equal to x plus 2 times 2x squared plus 2x plus 1. And I want to solve this is equal to 0. Okay, so again, this first factor, you can have x plus 2 is equal to 0, or this quadratic equation here, 2x squared plus 2x plus 1 is equal to 0. So one solution was just moving the 2 over, x is equal to -2. Sorry about that. Which you can see we got right here when we said it was a rational 0. All right, so now to solve this, you're going to have to use the quadratic formula again, okay, because this won't factor. So x is equal to -b, so it's -2, plus or minus the square root of b squared, so 2 squared, minus 4 times a times c, all over 2a, so 2 times 2. So this is -2 plus or minus the square root of, this is 4, looks like -8. Ooh, all over 4 is equal to negative 2 plus or minus the square root of negative 4 over 4. Well, this becomes 2i. So I'm going to move it up over here. So this is negative 2 plus or minus 2i all over 4. Or this is minus 1/2 plus or minus 1/2 I. Just because the 2 over, I'm breaking it up. It's and you can see that 2 divided by 4 gets you 1/2. So, okay, so we only have one real zero and we have 2 imaginary zeros. Okay, so the solution zeros are, so my solution set here would be minus 2 and then minus 1/2 I, and then minus 1/2 plus 1/2 I. So that was a crazy problem here, and it's okay to do this problem and get imaginary solutions. That's not too bad of an issue right there. Okay, it's going to happen, and it might even happen in the next exam. Okay. Whew, I know a lot with all these problems. So just to recap what we're doing here. Okay, you're given a problem. You're going to list all the possible rational zeros. Then you're going to use synthetic division to find a rational zero. Then you're going to rewrite this, all right, as the product, all right, of the rational zero and your resulting polynomial equation from the synthetic division, and then you're going to solve the resulting equation. Okay. All right, let's do a crazy one here. Okay. So let's do this. This will be our final example here. All right, and this is going to be a lot of steps that you're going to see, unfortunately. Okay, so let's solve this polynomial equation. Okay, x to the 4th minus 6x cubed plus 22x squared minus 30x plus 13 is equal to 0. Okay, so again, start by finding the possible rational zeros. Okay, so the possible rational zeros, it's going to be factors of the constant term here all over factors of the leading coefficient, which is 1. So this is going to be plus or minus 1 and plus or minus 13 over plus or minus 1. So really what actually works out here is your possible rational zeros are minus 1, 1, minus 13, and 13. All right. I'm just to expedite this example. All right. I'm gonna. Do you notice how you have some positives, some negatives here? So I'm just gonna pick positive 1. Okay. Like let me just see if positive 1 is a rational zero. All right. Well, actually, you know what? Let me start with negative 1. Okay, that'll actually help us later on in the problem. Okay. So I'm going to put negative 1 here. I'm going to put the coefficients 1, negative 6, 22, minus 30, 13. So bring this 1. Minus 1 times 1 gets me minus 1. You know, minus 6 plus minus 1 gets me minus 7. Negative, negative, this becomes 7. 22 plus 7 gets me 29. You can see this is just definitely probably not going to work out, right? Minus 1 times 29 gets me minus 29. When you add down here, you get minus 59. Minus 1 times minus 59 becomes positive 59, which is 72. Okay, so this is what we see here. Okay, thus, x equal minus 1 is not a rational zero. All right, so let's do 1 now. Okay, let me plug in 1 and see what happens. Okay, so again, The equation was, I'll rewrite the equation up here so we have it. It was x to the fourth minus 6x cubed plus 22x squared minus 30x plus 13 equals 0. So now it was, is x equal 1 a rational 0? So you're going to have to use synthetic division again, right? So 1 minus 6, 22 minus 30, 13. So bring down the 1. 1 times 1 is 1. Okay, minus 6 plus 1 gets me minus 5. 1 times minus 5. 22 minus 5 here gets me 17. 1 times 17 is 17. So minus 30 plus 17 is minus 13. Boom, it's going to work out. 1 times minus 13. Done. It's a rational 0. Okay? So this now, remember, this is where this problem gets crazy. See, this was x to the fourth. So now this is x cubed, x squared, x. So my equation, all right, my original equation was this. Let me actually go to the next slide here so we have it, okay? So my equation was this. X to the fourth minus 6x cubed plus 22x squared minus 30x plus 13 is equal to 0. So look, I saw that a rational 0 was x is equal to 1. So I'm going to bring it over as x minus 1. So this can factor into x minus 1 times. And then you got to look back. What was the resulting equation? X cubed minus 5x squared plus 17x minus 13. Whew, all right. So now it's like, okay, good. I did the synthetic division. Now I need to solve again. But here's where this problem was a little hard. You need to repeat the process on this right here. Okay, if it was an x squared here, like if there was no x cubed, you could be just like, oh, I'll just use the quadratic formula. So they need to repeat the process on this polynomial. All right, and this is where it's a little like, ugh. Okay, so I need to take this polynomial in here, okay? So looking at x cubed minus 5x squared plus 17x minus 13, okay? Possible rational zeros. So it could be factors of negative 13 all over factors of 1. So this would be plus or minus 1 over plus or minus 13 all over plus or minus 1. So you get the same ones. You get plus or minus 1 or plus or minus 13. Okay, so you need to use synthetic division again. And here's what's great. Did you notice how negative 1 didn't work the first time going back? Negative 1 didn't work. That means negative 1 won't work again. Okay, so when you have this, boom, it doesn't work. It won't work again. All right, so let's just try 1 again. Okay, let's try 1 again. So we're going to perform synthetic division on this. So bring down the coefficients. 1 minus 5, 17 minus 13. So 1 times 1 is 1. Minus 5 plus 1 gets me minus 4. Yeah, it's going to work out. 1 times minus 4 gets me minus 4. 17 minus 4 gets me 13. 1 times 13 is 13. Done. So we have a repeat here. Okay, so what this means, okay, is now I can rewrite x cubed minus 5x squared plus 17x minus 13 you can rewrite this as bring the 1 over, so x minus 1 times, this is 1x squared minus 4x plus 13. Whew, I know it was a lot, okay? So now we're there, okay, to solve it. So this is what stinks. When you did this, when you see something to the 4th power, you had to repeat this process twice. But look, we're basically there. Okay. So this is what we started with. We had x to the 4th minus 6x cubed plus 22x squared minus 30x plus 13 is equal to 0. Then it became this. Then it became x minus 1 times x cubed minus 5x squared plus 17x minus 13. And then it became, then this going back, I rewrote that x cubed as this. X cubed minus 5x squared plus 17x minus 3, I rewrote as this. So don't forget you still have this minus 1, this x minus 1. So then it became another x minus 1 times x squared minus 4x plus 13 is equal to 0. Oh, whew, I know, a lot of work here. So now you can solve this, okay? And I'm going to put this finally on one more final slide here, okay? So really it was x minus 1 squared times x squared minus 4x plus 13 is equal to 0. So you can either have x minus 1 squared is equal to 0, or this x squared minus 4x plus 13 is equal to 0. Here you see, even when you take the square root of both sides, you just get x is equal to 1. That's one solution, which we saw when we got the rational 0. And here you're going to need to use the quadratic equation again, unfortunately. So x is equal to negative b, so it's negative 4, plus or minus the square root of b squared, so minus 4 squared, minus 4 times a, which is 1, times c, which is 13. All over 2 times a, so 2 times 1. So this is x is equal to negative 4, so this becomes 4 plus or minus the square root. So what is negative 4 squared, right? That's 16 minus, 4 times 1 is 1. What is 4 times 13, right? So that's, you could do it as 26 plus 26 gets you 52. All over 2 times 1 is 2. So 16 minus 52 is 36. Negative 36. All over 2. So moving this over here, that becomes 6i. And then both 4 and 6 divide by 2 to get 2 plus or minus 3i. So my solutions. You could see x could be 1, then it could be 2 minus 3i, or 2 plus 3i. So this one was a little hard as you had to do that rational 0 thing twice, rational 0 theorem twice. All right, I know there was a lot going on here, and hopefully this video helped, but the key to these problems is be meticulous, and then follow the rules, okay? Follow the procedure that I have laid out.